In this session, we will learn how to solve n-queens problem using backtracking approach. What is n-queens problem? It is a classic combinational problem wherein you need to place n queens on a n cross n chessboard so that no two queens attack each other. So how the queens will attack? It can be either horizontal or vertical or diagonal. So as shown here, it can be horizontal, it can be vertical, or it can be diagonal. So why we are using this backtracking approach for solving n-queens problem? When a queen is placed in a column and it is checked for clashes with already placed queens, in the current column, if a row for which there is no clash is found, then that row and column is a part of the solution. But if no such row is found, then we need to backtrack again to find an alternative. So that is the reason we are using backtracking approach for solving n-queens problem statement. So for solving this n-queens problem using backtracking, let us explore first the number of queens that can be used. If only one queen is used, then the solution will be trivial. If there are two queens and the chessboard is 2 cross 2, we cannot place two queens, so there is no solution. If there are three queens and the chessboard is a 3 cross 3 chessboard, first queen can be placed here, second queen cannot be placed here, it can't be placed here, it can be placed here, but the third queen, same column, so it can't be placed. Here diagonal clash, so it can't be placed. Here column clashes, so it can't be placed. So only two queens can be placed. Three queens cannot be placed. So that is the reason for three queens also we don't have the solution. So let us now explore how we are going to place four queens in a 4 cross 4 chessboard using backtracking approach. For this, we will draw or construct a state space tree. So initially, the starting node contains a 4 cross 4 chessboard with no queens placed. So let us start exploring by placing the Q in the first row, first column. Then the second queen can be placed in the first column of the second row, or here or here or here. So there are four options. So the first option is not feasible. Why? Because a clash occurs. The second option, we will try placing queen in the second row, second column. So that is also not feasible. That is why we have highlighted these both in red colors. Fine. Now we will try exploring by placing the queen in the second row, third column. Yes, second row, third column, the second queen can be placed. But why I have given a red color here, indicating it as an infeasible solution? Second queen can be placed, but the third queen cannot be placed. Why? I cannot place my third queen here because same column. I cannot place my third queen here because diagonal clash. I cannot place my third queen here as well because same column clash. I cannot place my third queen here because there is a diagonal clash. So the third queen cannot be successfully placed here. So that is why it is an infeasible solution and red color is indicating. So now I have to backtrack, go back again here. So already the first queen is placed in the first row, first column. So now I have to explore by placing the second queen in the fourth column. Try with the next option. Okay, if I am placing my second queen in the fourth column, then I will try exploring by placing the third queen. Yes, third queen can't be placed here. Yes, but third queen can be placed here without any clash. So it is acceptable as far as third queen is concerned. But why I have written a box here, red box here, indicating it as an infeasible solution because fourth queen cannot be placed. So first queen was successfully placed, first queen was successfully placed here, second queen was successfully placed here, third queen also was placed successfully, but fourth queen cannot be placed. So here it is not feasible because of the clash. Here also not feasible because of this clash. Here it is not feasible because of diagonal clash. Here it is not feasible because of column clash. So fourth queen cannot be successfully placed in this option. That is why I have indicated that as an infeasible solution. So I have to backtrack. So where will I go? I will move here. So all these options were tried when I have placed my first queen in the first row, first column. So I will go back here. So now from here I have backtracked to the initial node. So now let me start exploring by placing my first queen in the first row, second column. That is this option. So first row, second column, first queen is placed. Second row, first column, the second queen can't be placed. It can't be placed here as well. It can't be placed here as well. It can't be placed here also, but it can be placed in the fourth column. Yes. Now let me explore for placing the third queen. So third queen can be placed in the first column. It cannot be placed in the second column because of this clash. It cannot be placed in the third column because of diagonal clash. It cannot be placed in the fourth column because of vertical clashes, but it can be successfully placed in the first column. So this is acceptable. So successfully we have placed first queen, second queen and the third queen. Now let us explore placing of fourth queen. So fourth queen cannot be placed in the first column because of vertical clash. It cannot be placed in the second column because of vertical clash. It can be placed in the third column, no clashes. It cannot be placed in the fourth column because of vertical clash. So in this set, I have successfully reached my solution without any clashes in the queen. So this is one of the solution. Next, one more important thing. In backtracking, there are possibilities of so many feasible solutions. So it is not a hard and fast rule that there should be only one solution. There are possibilities of so many solutions. So as of now, we got one solution. We have to explore by placing the first queen in the third column and the fourth column to identify if at all any other solutions are available. So let us explore placing the first queen in the first row, third column here. It has been successfully placed. Let me explore for placing the second queen. Second queen can be placed in the first column without any clashes. Second column, no, because of diagonal clash. Third column, no, because of vertical clash. Fourth column, no, because of diagonal clash. So it is successfully placed. Now let us explore how third queen can be placed. The third queen cannot be placed here because of vertical clash. It cannot be placed here because of diagonal clash. It cannot be placed here because of vertical clash, but third queen can be placed in the fourth column successfully without any clash. So we have placed first queen, second queen and third queen successfully. Now let us try for placing fourth queen. Fourth queen cannot be placed in the first column because of vertical clash. It can be placed in the second column, no clashes. In the third column, no, because of vertical clash. Fourth column, no, because of vertical clash. So this is yet another feasible solution wherein I can place all my four queens successfully. And we have to go backtrack again and check whether there are feasible solutions when I place my first queen in the fourth column. So I'm coming here. I'm exploring for placing my second queen. Yes, second queen can be placed here without any clash, but third queen, let us check whether third queen can be placed. Yes, third queen can also be placed, but there is no feasible solution for placing my fourth queen. Why? Because if I place here, it will be a clash. If I place here, it will be a diagonal clash. If I place here, it will be vertical clash. Here also vertical clash. So no feasible solution. I can't place my fourth queen. That is why it is indicated as a red box here. Then I will backtrack, go back here and start exploring for placing my second queen again. So second queen can be placed successfully in this position. Third queen cannot be placed here because of diagonal clash. It not here because of vertical clash, not here because of diagonal clash, not here because of vertical clash. So there is no possibility of placing my third queen without clashes. So that is why it is infeasible. So I have explored all the possible ways of placing 4 queens in the 4x4 chessboard, and I have found 2 possible solutions. So this is my first solution and this is my second solution. So there are 2 possible solutions: placing queens at 2, 4, 1, 3 and 3, 1, 4, 2, which is the mirror image of the first one. The second one is actually the mirror image of the first one. So here is the n queens algorithm. In n queens algorithm, first we have to find out whether I can place my queen in a position without any clash. So if this place function returns true, then I will place my queen in that particular row, and if all the queens have been placed, then I will create an array storing my results. If not, I will check for placing my queen in the next row. So for that placing function, here is the code. So this will return either true or false. So I need to check for clashes: vertical clash, horizontal clash and my diagonal clash. If there are clashes, this will return false, else it will return true. So based on this true and false, we will place the queen in the correct position, and then we will check whether we have placed all the queens, or else we will start exploring the next queen. And the complexity of this is n factorial. Why? Because the n queens, or in the worst case scenario, every queen must be tried in every column of every row. So that is why it is n factorial. Hope you are clear with the concept of placing 4 queens in 4x4 chessboard, and the same can be used for any n queen placing in n x n chessboard. Thank you.